All right, think about the flawless, glossy finish on your phone case or the door of a car, maybe even a high-tech medical device. Have you ever stopped and wondered how they get it so absolutely perfect? Well, the answer is this really fascinating manufacturing tech that gets the finish just right before the product is even, well, finished. And that's really the secret, right? It all comes down to this one question. How in the world do you apply a perfect finish to something before it's even fully made? I mean, it sounds kind of like magic, but it's actually some incredibly clever science and engineering. And that clever science, it has a name. It all comes down to a process that happens right at the very heart of manufacturing. Yep, you guessed it, inside the mold itself. It's called in-mold finishing, or IMF for short. And the main idea is actually pretty simple, but it's totally revolutionary. You apply the finish directly inside the mold, either while the product is forming or right after. The best way to think about it is like baking the icing right inside the cake, all in one go. It just completely merges the finishing step into the main manufacturing cycle.
Okay, so you might be thinking, why go through all that trouble, right? Why not just paint or coat things the old-fashioned way after they're made? Well, it's because finishing inside the mold is a total game changer for both the quality of the product and for making things way more efficiently.
To really get it, we first have to meet the arch nemesis of any perfect finish, coating defects. See, when you apply coatings after the fact, you are in this constant battle against all these tiny little flaws that can just ruin the look, the feel, and even the function of a product. And trust me, this is not just a small annoyance. Research from Noguchi and their team points to a major culprit: tiny little air bubbles. Just as this quote explains, these trapped bubbles can cause craters and these things called fisheye defects that don't just look bad, they actually weaken the entire coating. And this is where IMF just shines. By controlling the whole process inside the mold, you get this incredible consistency. Research from Wang and his colleagues actually shows that a well-optimized IMF process can boost the coating's uniformity by 15 to 18%. A more even coat means it looks better, sure, but it also means better protection and a much longer life for the product. But it's not just about looking good. With IMF, you can build advanced functions directly into a surface. Get this, researchers have used it to create biomedical implants with these specialized titania coatings. And the result? A mind-blowing 100% antibacterial efficacy. That's not just a little improvement, that is a massive leap forward in medical tech. So, how is this actually done? You know, IMF isn't just one single method. It's more like a super versatile toolbox with all these different tools for different jobs. This lets engineers pick the absolute perfect technique for whatever product they're making. First step in the toolbox is a concept you're probably familiar with, but with a serious, high-tech twist: spray coating. This is one of the most flexible and widely used techniques in the IMF world. Its biggest advantage is its flexibility. I mean, it's fantastic for evenly coating really complex 3D shapes. But the catch is precision. You have to control every single variable because that's what's critical to avoiding those tiny defects we were just talking about. You'll see it used for pretty much everything, from car parts to major industrial pipeline repairs. Next up, we've got a method that's all about creating these perfectly even ultra-thin layers. It's called dip coating. This is the go-to technique when absolute, total uniformity is the #1 goal. So, dip coating is amazing at creating incredibly consistent films where you can control the thickness down to a science. This makes it perfect for high-tech stuff like electronic sensors, and yep, this is the method they use to create those advanced bioactive and antibacterial surfaces on medical implants. And for our third tool, we are diving into the world of plasma. These techniques are what you pull out when you need to create a surface that is just ridiculously tough, durable, and resistant to pretty much anything you can throw at it. So how tough are we talking? Well, research shows these methods can create ceramic-like surfaces with a hardness value over 1426 HV. That is incredibly hard. But even better, they form a powerful metallurgical bond with the material underneath. The coating doesn't just sit on top, it basically becomes one with the part, giving it amazing resistance to wear and corrosion. Okay, so we've seen what IMF is, why it's so important, and the tools it uses. Now let's peel back just one more layer and look at the fundamental science that makes this all possible. Let's geek out a little bit. It all comes back to those pesky bubbles. The science here is actually really cool. In a controlled IMF process, any tiny air bubbles that get trapped just shrink and disappear as the coating dries. Poof, gone. But in a less controlled process, the bigger bubbles get stuck, they expand, and that's what creates those craters and fisheye defects that just ruin the surface. And the creation of the film itself is like this precise little three-stage dance. First, you have deposition, where droplets land on the surface. Next, they start to overlap and merge together. And finally, you get leveling, where the liquid flows out to create that perfectly smooth, uniform film we're all after. Controlling each of these stages is the real secret to a flawless finish.
But, a perfect finish is totally useless if it just peels right off. The final piece of this whole scientific puzzle is adhesion, making it stick. Through some really clever chemistry, like creating special inner layers and engineered chemical bonds, IMS makes sure that coating sticks with extreme durability. It forms a truly integrated and resilient surface.
So when you put all of this together, it becomes really clear that in-mold finishing isn't just some niche little technique. No, it's a foundational technology that is truly shaping the future of how we make things. When you boil it all down, the IMF advantage is really four things. It's faster, because you're combining manufacturing and finishing into one step. It's stronger, creating more durable and uniform surfaces. It's smarter, enabling incredible functions like self-healing or antibacterial properties. And it's even greener, because some of these techniques can seriously reduce the amount of chemicals and water you need in the whole manufacturing process. I mean, we've already gone from just simple finishes to creating antibacterial surfaces, all built in one step. This technology is just constantly evolving. So the real question to leave you with is this. As our products get smarter and more complex, what's next? What other incredible functions will we soon be building directly inside the mold?